All right, let's open up Module 2, Lesson 3, and dig into something that sits right at the heart of how every network actually moves data: switching methods. In this lesson, we're going to unpack how a switch processes an incoming frame and decides where to send it next. And the big tension we'll keep circling back to is store and forward versus cut through, reliability on one side, raw speed on the other. Before we get to those decisions, though, we need to know what the switch is actually looking at. An Ethernet frame has 5 key parts: the destination MAC, 6 bytes telling us where it's going; the source MAC, 6 bytes telling us where it came from; a 2-byte type field, the payload itself, anywhere from 46 to 1500 bytes; and finally, the FCS, 4-byte at the tail. The switch uses the destination to forward, learns from the source, and leans on that FCS to catch any corruption along the way. Now that we know what's inside a frame, here's how switches actually handle it. And there are 2 schools of thought. Store and forward pulls in the entire frame, runs that FCS check we just talked about, and only forwards it if everything looks clean. Cut-through is the speed demon. It reads just the destination MAC and starts forwarding immediately. No error checking, no waiting. That's why you see cut-through in data centers where every microsecond matters, while Cisco defaults to store and forward, reliability over raw speed. Stepping away from forwarding decisions for a moment, let's talk about the link itself. Full duplex means a device can send and receive at the same time. That's every modern switch port, and collisions simply don't happen. Half duplex is the old hub behavior, one direction at a time, with collisions on the wire. These days, auto negotiation handles speed and duplex for you, but when it goes wrong, one side full, the other half, you get a duplex mismatch. The link still works, but it's slow and full of errors. It's one of the classic troubleshooting catches in the real world. So let's bring it all together and follow a single frame through the switch. It arrives on a port, and the very first thing the switch does is learn. It records the source MAC against that incoming port. If we're doing store and forward, the FCS gets checked next, and a corrupt frame is dropped right there. Then comes the lookup. Find the destination MAC in the table and forward it out the matching port, or if it's unknown, flood it everywhere except where it came from. Learn, check, lookup, forward. Every frame, every time in microseconds. And that's the foundation: frames, MAC tables, and forwarding decisions. Next lesson, we move from theory to the keyboard. Basic switch configuration, where you'll actually log into a switch and start shaping its behavior from the CLI. If this clicked for you, hit subscribe and turn on notifications so you don't miss it. And the full course is waiting for you over at dargslan.com. See you in Lesson 4.